Good morning, students. In today's class, we'll discuss about the good morning, students. In today's class, we'll start the new topic that is Unit Fifth, lasers. Right. Unit Fifth is having two chapters. One is laser, and another is optical fiber. So, in last class, we discussed about the uh, various applications of superconductors, and then we have gone for the BCS theory, that is Bardeen Cooper Schiffer theory, which in which they propose that the interaction between the two electrons will be possible by means of a phonon. So now this particular aspect we studied in the last class, and also we discussed about the high temperature superconductors. Now how these high temperature superconductors are uh, classified, and what are the research which is going on in high temperature superconductor. So here we are interested in making these superconductors at room temperature. So now that research is still going on, and probably uh, we expect that the superconductors can be available at room temperature also. So in the meanwhile, in today's class, we'll discuss about the lasers, right? So before going to the lasers, what is the actual full form of laser, right? You already aware of this fact that what is actually the acronym of laser. So the laser is nothing but light amplification of stimulated emission of radiation. So now when we say laser, laser is an what you can say how the laser is different from the normal light. So in today's class, we'll discuss the uh, possibilities, three possible ways through which the laser is interacting, light is interacting. We just start our today's topic with the how these lasers are interacting with the matter, and what are the things which is possible when they are interacting with the matter. So, that particular thing, and then we'll just move on to the important topic of the population inversion, and also we'll discuss different what you can say manufacturing steps of the laser, how laser can be built up. So now, first of all, before starting on today's class, we just we should know that actually how these lasers are classified as the mm, lasers. Now, how these lasers have been classified as. So there are different types of laser. You'll find that solid laser, liquid laser, and gaseous laser. So now, uh, moving forward, we need to understand what is the basic difference between the laser light and the normal light. So the laser light is having a special characteristic. So here, what is that special characteristic? In the lower classes, you studied this, right? It is having high intensity when compared with the normal light. So very high intensity will be there. This is a special character of the laser. And also, it is having high monochromaticity, high monochromaticity, monochromaticity, high intensity, high monochromaticity, right? Coherence, right? You'll have a special property of coherence, right? High directionality. Now, these are the special character, how these lasers are different from the normal light. So, high directionality. So, these are the important characteristic of the laser. So now, in today's class, we just discuss about the laser interaction, the later in laser interaction with the matter. So what is actually happening when the laser is interacting? laser interaction. So laser is interacting with the matter. So as the laser is interacting with the matter, what is actually happening out? What is possible when the laser light is interacting with the matter? There are two things possible. One, maybe the light will be absorbed, so we just call that as absorption, right? And maybe light will be emitted out, right? So two things are possible. It may be uh, absorption, or it may be the emission. So here, what you can say that these emission, right, is again divided into two categories, right? So one is spontaneous emission, one is spontaneous emission, and another is stimulated emission. One is spontaneous emission and another is the stimulated emission. Now, this is possible when the light is interacting, laser light is interacting with the matter. So, for normal light, spontaneous emission may take place, right? So, what is this actually absorption? What is spontaneous emission? What is stimulated emission? We'll just discuss in today's class, and also we'll just try to derive an equation related to it. In the examination, he will ask you explain the uh, laser interaction with the matter. Explain the phenomena of laser interaction with the matter. There is a possibility, and this you already studied in your lower classes also. So now, so laser is having a special characteristic of from the normal light. How this laser light is different, right? So it will have a high intensity when compared with the normal light, or we just say high monochromaticity. Single mono is single colored light. High coherence will be there. The coherence may be spatial or temporal. So high directionality will be there when compared with the normal light. So now we just concentrate on this laser interaction with the matter. So what is actually happening when laser is interacting with the matter? So when the laser is interacting with the matter, either absorption is taking place or emission is taking place. So which type of emission? So it may be spontaneous emission or it may be stimulated emission. Then again the question arises, why the emission is spontaneous and why it is stimulated? We just let us see what actually will uh, do, right? We just start our right with the absorption. So now I think that you got very clear idea. So what actually we are trying to do here? So we want to study the interaction of laser with the matter. So now first category of first we'll deal with the absorption. When you just see this, when the light laser light is interacting with the matter, so the first possibility is absorption. The first possibility is absorption. So what will you do now? Or what is actually happening here? So here we just first we draw this schematic diagram, right? So now let us consider this mm, downward value as E1, and we just say that is called a ground state, and the higher energy state is E2. Now, let us consider an atom is there residing at the energy level, ground state energy level E1, and we just call this as this atom is considered to be the atom before absorption of the laser light, right? Before absorption, before absorption, you'll find that the dot here indicates, resembles the absorption. So what is happening when the laser light is made to incident on this atom, right? Now let us consider this is the light, right? Now, which type of light? Now let us consider this is what E1 and E2. This is E1 and this is E2. Now, when these laser light is interacting with the atom which is residing at the what you can say at the ground state, So the next step will be the as it is observing the energy, the atom in the ground state will move to the higher energy state. Now this atom will move to the higher energy state as the it will observe the radiation. So radiation is observed by the atom and it is moved to the higher energy state. So now this is what even now during interaction or during absorption, right? This is, we'll just consider this is happening, the light ray is approaching the atom. So during absorption, this thing is happening, and this is what after absorption. This is after absorption. This is happening after absorption. Now, the emission of radiation may be occurring in two ways here. So this is what the absorption is taking place, and the radiation here. Now you can just see this. Now, see. Uh, what you can say is that the let us we'll just go to the emission part. Then the second important aspect that will deal with the emission, right? So here the emission may be of two different types. So we just write it as emission of radiation. The emission of radiation can occur in two ways, right? They can occur in two ways. So the emission of radiation can occur in two ways. Now that is which is nothing but a stimulated emission. Just now we discussed, right? That may be stimulated emission, stimulated emission, and the second one is spontaneous emission. Now this is the two possibilities that may occur, right? So it may be stimulated emission or it may be spontaneous emission. Now, what is this stimulated emission is all about? So this particular concept is actually given by Einstein, right? You need to remember this, that the emission of radiation which is occurring in this it may be stimulated or spontaneous. This particular concept was given us by the scientist called Einstein. Now this emission possibilities is given by the scientist Einstein. Now we just discuss what is actually stimulated emission schematically, right? So stimulated emission, when we deal with the stimulated emission, right? So what is the stimulated emission is? Stimulated emission, right? So we'll deal with the stimulated emission. So what is happening, right? So now since you can observe that as the in this particular case, see absorption, now the atom is at the uh, higher energy state. From here it will try to come back to its original state. So these while coming back to its original state, that is a ground state, so it will be emitting some amount of radiation. So what is the stimulated emission? So what is this? Then we just say that when radiation is interacting with matter, when radiation interact interacts with matter, when radiation is interact when radiation interacts with the matter is nothing but matter is composed of atoms, molecules, and so on. So now, so when radiation is interacting with the atom, right, which is already there, right, which is already which is already so which is already in the excited state, which is already in the excited state, which is already in the excited state, right? So this excited state is nothing but we just consider this as E2, right? So now the what will happen when the excited state, the atom is there in the excited state. So the excitation of atoms will possible. The de-excitation, we just call that as de-excitation of those atoms of the atom. We just consider that as an atom here. So of the atom, for our comfortableness, right? You'll have different atoms. So de-excitation of atoms to the ground state, to ground state, to the ground state, that is E1. Clear, everybody? Now, what is this semantically look like, right? And how it is coming back with 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 two photons, with two photons, with two photons, right? So when you just see this type of figure here, this is what E2, and this is what E1. This is E2 and this is E1. Now, the photon from here will, right, is made to is incidented. So how many photons are coming? There are two photons which are emitted while the atom is coming from the excited state. So now this is what we just call this as external source. We are applying some external source here, external source in the form of the photon. So now the atom which is coming towards the even state, so while it is coming towards the even ground state, we are exposing that atom to the external source that are nothing but the photon which is having the energy h nu, where h is the Planck's constant and nu is the frequency of the emitted radiation, right? Now, so what is the output you'll get? You'll get two photons here, right? So now this is about the stimulated emission. See, again, I'm just start. See, we just started that how the radiation is interacting with the matter. So when I say matter, it composed of atoms and molecules. So what is a primitive what is a primitive substance that is available? That are atoms. So let us consider, in order to understand this absorption and emission, we are considering that, let us consider that there are two energy levels. One is E1 and E2. So E1 is the ground state and E2 is the excited state. So now the atom is residing at the ground state. So and now what is happening is that we are applying some here, we are just applying the external source here. What is that external source? Photon light radiation is interacting with the atom. So as you can just see that during absorption, so the atom is going to the higher energy state after observing the atom, right? After observing the energy which is having the value as E is equal to h nu. Now, now what is happening is that the atom will not stay for a long time in the excited state. It will try to come back to its original state. So while coming back to its original state, that is a ground state, it will emit the radiation, and this radiation which is emitted, there may be possibility as given by the Einstein that the emission of radiation can occur in two ways. Either it may be stimulated emission or either it may be spontaneous emission. So when I say stimulated emission, the radiation is interacting with the matter which is already in the excited state. Then the de-excitation of the atom is taking place to the ground state with the two photons. Now what we are doing is that while the atom is coming back to its original state, before that we are exposing this atom to the external with the help of an external source that is having the energy h nu. So since the atom, as it is coming back to its original state, it will emit the uh, radiation, and that radiation will have the energy as h nu. Now this is happening, and now the output, what we will observe, that there will be two photons, right? Now the last one that we'll discuss today's class is spontaneous emission. Now, see, we'll go very slowly, right? Why? Because uh, you need to understand this concept, which is very, very important for the next topic, right? So now, spontaneous emission. You can just see spontaneous emission. Just now we discussed stimulated emission, which is nothing but which is happening inside the optical fiber. What is the basic principle on which the optical fiber is occurring? So stimulated emission. Now spontaneous emission, what is actually the spontaneous emission? So we consider this category, right? So I already told you that there are two categories here that may be a spontaneous and stimulated emission. Now, since the we just take the what you can say, the case of absorption where the atom is at the higher energy state. Now let us consider this is energy level E1 and this is the energy level E2. So this is the excited state. So what is happening here is that uh, the atom is coming back. So there is another possibility of emission of the atom. So here, without applying any external source, so you will get an photon here. So no external source is applied here. So now this is happening in the spontaneous emission. External, no external source is applied here. So we don't apply any external source. So we don't apply any external source. Spontaneous emission. So here, spontaneous emission is nothing but emission. See, of emission of atom, emission of atom. So here the emission of atom when it is de-excited, right? Or when it is coming back, right? When it is de-excited. De-excited means coming back to its original state, that is ground state. So de-excited from E2 to E, from E2 suffix to E1, from E2 to E1 in the absence of 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 external in the absence of external stimulating radiation, external stimulating radiation, stimulating radiation, right? We just call that as stimulation. So um, so where there is no external sources applied. Now this is possible when the light is interacting with the matter. You can just see again, I will explain you what we discussed. This is because this concept, if you can understand, so I think that the next class will be for next one, it will be very, very easy for you to understand the derivation, that is Einstein coefficients. So here the light is interacting with the matter, right? So you remember that when I say matter, so it consists of atom. So as the light is interacting with the matter, so there is two possibilities, right? So what is that possibility? Either light radiation will be observed. So absorption is possible. And again, there is a possibility of emission. Now, this is very, very important to understand. So either absorption is taking place or emission is taking place. So absorption means light is made to incident on it, right? Incident on the atom. Emission, so emission is possible uh, right, by means of uh, two categories, right? It may be a stimulated emission, or it may be stimulated, or it may be spontaneous. So now, what is the meaning of stimulated? You are applying external source, external source, right? Here, you don't apply any external source. The atom which is there in the excited state, it will come back. So this is happening in our normal conventional light source, right? So the conventional light source, whatever will take that light source, you don't find any external source to it. So you don't require any some instigating thing to the atom. So it will by itself, it will, as it is reaching the higher energy state to the E2, it will emit the radiation while coming to the ground state. This is happening in the normal conventional source of light. In the particularly when we talk about the stimulated emission, so the stimulated emission in which we require some external source. So with this concept, right, we can just move forward. In the next class, we'll discuss about the Einstein coefficients. This particular concept has actually given by the Einstein. So we'll just discuss this. How, see, what is our aim in studying this laser light? So the laser light will have is having lots of applications. So first of all, we need to understand what are the concepts which are related to the light radiation, right? So here we'll just this particular concept of either it may be the two types of emissions which is given by the Einstein. We'll discuss the mathematical verification. Mathematically the Einstein has given us the relation, right, between spontaneous and stimulated emission. So mathematical derivation is there. So that derivation will derive in the next class to understand more clearly what is spontaneous and stimulated emission mathematically look like, right? So with this, I will just take a leave for today's class. Thank you, everyone. Thank you for your patience. Right. Which will end this today's class for now.